Hi, Willem. No, I have a zero experience of school. I guess we should start. Okay, not an issue because right now only I guess only 3 to 4 session left. Okay, after this, I'm not going to teach again. Maybe you're busy with school or something, right? But it's good to see you again. Okay, so I guess we have to start now. Okay, so this is going to be our first session on the same on this chap for this chapter. I'm sorry, that is a mine. And like weightage wise as compared to the other inorganic chemistry, organic chemistry chapter, this is very small. Okay. Okay, I can understand because right now you're in 12th class, right? So, not an issue. So let's continue. So let's start with the basic part, like what does amine, why we are using amine, there is any use of amine in our day-to-day life, so these kind of things. So let's just start with the point number one, that is amine. So mind the compound in which one or more hydrogen atoms replaced by the R there. For example, if let's suppose this is ammonia group, okay, this is NH3 group, and one hydrogen replaced by some kind of R. For example, let's suppose that is one hydrogen is replaced by some R is there. So it's become that is amine group, it's become amine. So this is simply the meaning of amine. So it's written not simply that is when one hydrogen replace here. So it's become primary amine. Okay, it's a primary amine. If two replaced, so it's become secondary amine. If all three replace, so it's a secondary amine. If all three replace, so it's become tertiary amine. So this is how we are end up with different kind of amine there. So I hope this point is clear now. If you're observing the ammonia, if one hydrogen replaced by R, so it's become primary amine. Okay, this is my primary amine. And when second hydrogen also replaced, so it's become secondary amine. Okay, if both hydrogen replaced there or all three replaced there, so it's become tertiary amine. So this is normally the amine. Now the next question, that what is the use of amine in our day-to-day life? Okay, so let's discuss about the uses part as well. So uses part wise, the point number one, importance. Have you ever observed the capsules, right? So you know the coating of the capsule, the thing that is dissolved. Okay, it's dissolvable in our body there. So this, let's suppose this is a capsule. Okay, like this is a plastic kind of cover on the capsules, and this is biodegradable, and once it's entered in our body, so it's automatically degradable. Okay, so this is made up of amine there. The chief commercial use of the amine as an intermediate in the synthesis of medicine and fibers, especially like this coating is made up of this Benadryl. Okay, so Benadryl, a well-known antihistamine drug, and also that also contain tertiary amino group. Okay, antihistamine means, for example, you know that yes, Shiva, you're right. Okay, okay, not an issue. Venom, if you regularly attend the classes or watch the classes of the chemistry regularly, so I guess it's not difficult for you. If still you are facing the problem, just connect with me personally as well. Okay, venom. So yes, what we're discussing, what is the meaning of histamine? So like basically, you know that our acidity of the stomach is approximate 0 to 3 pH. Okay, maximum pH is the 3 there. So let's suppose this is the wall, like this is how our stomach look like. Okay, so there's a wall of the duodenum. This is J safe, like maybe you already know from the elementary track of the 10th class. Okay, so this is a stomach, and the wall of the stomach, there is a kind of enzyme, you can say. Okay, so the name is like histamine. Histamine is basically a main cause for increasing the acidity in our blood. Okay, so if you want to suppress that, we are using antihistamine drugs. Okay, so like this is just a cure of that stomach pain. So like that's enough for the like math student. Otherwise, like it's a very important kind of topic in a biology, right? So this is simple. Not no need to observe this. Simple. The observation is what? That is in antihistamine drug. That if you want to suppress the acidity there, okay, we are using tertiary amino group. So that's it. Now let's see more uses there. Look at this. This is what, that is a novocene. What is the novocene? Okay, so maybe have you ever visited to the dentist? Hopefully no, right? So you know there's a kind of injection, and that doctor injected in our gums there, so that we are not feeling anything. It's be like anesthesia. Okay, so that Navocin, a synthetic amino compound, is used as an anesthetic in sorry, that is the dentistry. Okay, and the next one is what? That is, this is kind of a what? Rope. Okay. Have you observed the bungee jumping and all these things there? So there we are using a artificial kind of rope. So that is made up of basically the nylon there. So synthetic polymer like nylon, hexamethylene diamine, and it's very famous for its name. That is the nylon 66. Okay, so right now polymer is deleted from your syllabus. Otherwise, we are going to discuss about this topic also in very detail there. Okay. Yeah. So, so let's observe this. This is nylon 66. Then some more uses, that it's a B9. So you know that vitamin B is a like common vitamin, and it's further classified into the B6 just because of the different kind of group have to be there, or vitamin B12, and similarly it's a vitamin B9. So like vitamin B is further divided into different kind of like enzyme there. And then this is known as a vitamin, and this play a very much important vital role in our body. I guess you already know, if there is a deficiency of vitamin B in our body, so we are suffering from beriberi disease. Okay. Again, it's very normal science class question, right? So beriberi disease. Don't worry, in the biochemical chapter, we are going to discuss about the vitamin in very much detail. So we there we're discussing again. So it's a again it's a vitamin amine. So here in the structure of the vitamin B12, yes, there is a amine present there. And the next one is what? Quaternary ammonium salt or are used as a surfactant. Okay, I'm not saying it's a soft solution, it's a surfactant. Okay, surfactant simply. That is the surface acting reagent, or in our layman language, the detergent powder which we are using right now for washing the clothes, right? Because right now, I guess no one is using soap frequently just because of the hardness of the water there. Okay, so that's it. Now let's continue further. Now let's discuss about the next point, that some other nitrogen containing compound. So it's not like chapter name is amine, so amine is the only topic of discussion there. So like amine is just a type of the nitro compound or nitrogen compound simply. So nitrogen compound further classified into nitro compound, like if you're observing NO2 group, or nitrile compound, cyanide compound if carbon connected, if nitrogen connected, so it's become isonitrile. And this is amide again, and this is imide. So in this chapter we are going to discuss nitro as well, cyanide part as well, amide as well, or imide as well. Okay, but the main topic is going to be the amine. Yes, that doesn't, you're right. So let's back again. So what we're discussing now. So observe this. This is all for the nitrogen containing compound. Now, like every time after once we're starting with the chapter, then basic things. How does the structure look like? Classification, nomenclature, then physical property, preparation, chemical property. So let's just first talk about the structure. And yes, this is very simple. What is the structure of the amine? Like options are tetrahedral, or like planar or triangular plane, like which kind of structure? Yes, please, anyone, what is the structure? Let's just talk about the structure of amine. So let's just start with the ammonia, right? It's be like when we are replacing a hydrogen with some R groups, it's become amine. So what? Let's try to understand. It's very simple. So let's compare with the ammonia. You know, everyone ammonia has a lone pair. There is some hydrogen group is connected. So it's what? It's basically that is the tetrahedral is the geometry there. But just because of the Vesper theory, due to the lone pair bond pair repulsion, it the shape become that is the trigonal planar. Sorry, pyramidal. So it's a trigonal pyramidal is the shape there. And how about the angle in this case? The angle is what? 107 degree. I hope you know the angle as well. Now, my next question to you, just let me know what is your answer. Just simply, what if in this question, I'm replacing the hydrogen with some R group. Okay, let's say this R. So can you just tell me the bond angle? The bond angle. Options are, let's suppose this is some theta. Theta is the bond angle. So after once R group is connected there, okay, so the bond angle theta is equal to 107, like the ammonia, or the theta is greater than 107, or theta is less than 107. This is a very basic chemical bonding question. Yes, please. According to you, angle increasing, decreasing, or what? Increasing. Yes, very good, Venom. So, yes, in this case, how the angle or like how about the angle? So, angle is approximate 108 there, okay? So, but why? So, look at this that, for example, if let's suppose this nitrogen is the central atom and this is R in our group, okay? So, let's just change this R with some methyl group, okay? So, R can be any ethyl, methyl, or any group. So, everyone, I guess you know that is how really the methyl look like, right? This is how it's look like. And once we are using this kind of structure, so obviously something is connected with the hindrance. So what is going to happen that these two are the bulky group and the repulsion between them. So just try to understand when you need to repel something. So just because of the repulsion, this angle increasing there. Okay. So hence, just because of the repulsion between the R group, the angle is increasing there. Okay. So the see the change that 107 become 108. So this is how the angle increasing there. Okay. Very good evening, sir. So you are right, basically, Venom. So I feel like you are saying you don't know the basic, but still very good for this. So let's just back again what we're discussing, that structure part, right? So structure, yes, just back here. Look at the angle change now. So if you're observing 107.3 become 108, ammonia, and this is tertiary. It can be methyl ether or any group can be there. Okay, so this is all for the first point, that is the structure part there. So let's just back again. After the structure part, next is going to be the classification. So classification on the basis of what, that you know, primary amine, tertiary amine, or like how to classify this. So let's talk about the classification part. The first classification based on the type of group attached to the nitrogen. Okay, so let's see how to classify this point there. So let's observe some cases there. If we are observing, this is what, this is alkyl amine. R can be aryl or R can be alkyl. Okay, so like for example, okay, so for example, if let's suppose a kind of aromatic system I am using, okay, and let's suppose this is some NH2 there. So obviously that R we just discussed, right? R, so it's aryl group, so it's become aryl amine. Okay, it is nothing, it's simply a arylamine. But on the other hand, let's suppose this is some CH3 group, okay, like this, so it's become alkyl amine. So it's simple that alkyl or arylamine. So this is simple classification we already know. So yes, here. So that's it. This is simple. This is alkylamine. This is arylamine. And the last one is what? Heterocyclic compound. So in the organic chemistry, if other than carbon or hydrogen, any other group is present there, so yes, that is counted as a hetero group. So like if you recall the 11th class classification part there, so for example, that let's suppose this is a kind of normal ring, and what if nitrogen group is connected here like this? Okay, so it's what? It's a heterocyclic. Okay, heterocyclic amine there. Or some example that these are the famous one. If let's suppose the double bond like this, so it's become pyridine. I guess now you are familiar with pyridine. And one more, that if this 5 membering is there, so it's become pyrrole. So pyrrole and pyridine are the famous ones. So it's a pyrrole, it's a pyridine, and then this is a new and then cyclic compound at least with one nitrogen compound. It's become heterocyclic amine. Okay, this is all for the classification based on the that is the type of group attached to the nitrogen there. Now let's see the next classification, that the classification number two based on the number of group attached to the nitrogen there. So like typical primary amine, secondary amine, on the tertiary amine part here. So amine are classified into the primary, secondary, and tertiary. If one hydrogen replaced by R, so it's become primary. If two hydrogen replaces, it's become secondary. If one had all three hydrogen replaced there, so it's become tertiary, right? So why I'm explaining in very much speed, because we already know, right? So that's why I already explained just in the very start of the class what is primary mean, what is secondary, and what is tertiary there. And after this, the next topic is going to be the nomenclature. Okay, so every time that our nomenclature is classified into the two part, one is the common nomenclature, right? Common name, simply nomenclature, or the name. Okay, so common name, and one is the IUPAC name. So IUPAC, little bit we know from the 11th class, but common name is a new for you. So let's see how about the naming there. So let's discuss about the naming portion. Okay, observe this. So these are the common name. Like in this case, let me just explain this on the next slide. Isopropyl. Okay, let's just suppose this is some nitrogen and this is connected with this some CH3 there, and then one more carbon and it is further connected with 3CH3. Let me just check, is this present there? And it's 2CH3 and carbon and CH3. Okay. This is CH. Okay. CH3 and CH3. So in this case, got it like this. So in this case, this become like this is a iso group, if you remember that this is a Y kind of structure. So yes, if you're observing this is a Y and this is NH2 group. So it's become isopropyl because three carbon and then amine. So it's become isopropylamine. It's a common name, it's not a IUPAC name. Okay, so this is the first one. And now let's see more common name. Let's just back toward the slide again. No, this is not. Yes, here. Okay, so this is isopropylamine, and in this case, two carbon, so it's become ethyl. That normally two carbon ethyl amine again, and in this case, this is ethyl methylamine. Okay, so in this case, if you're observing, one is the CH3 group, so methyl. One is the CH2 CH3 group, it's become ethyl. So ethyl methylamine, and here you have to follow the alphabet. Like E come first alphabetically as compared to the M, so that's why E there. Okay, which part is not visible? Like what you don't. Okay, maybe I miss your chat. I'm sorry for this. So let's just observe this again. It's a two carbon, it's a three carbon. So it's become ethyl, it's become propyl, and it's a amine there. And in this case, three CH3 group connected, so it's trimethyl amine, and then it's a two diethyl butyl amine is there. Okay, so common name we are most probably going to use in the reactions. Okay, if you don't know the IUPAC, so it's not an issue. Now let's see some more common name. This is really important. Aniline. This is aniline, and it's like in this case, one, two, three, and four. It's a four amino group and then toluene there. And then in this case again, if you're observing, this is one, so it's become N methyl, and this become that aniline there. So it's N methyl aniline. Wait, to highlight how that this portion is the aniline part, right? Aniline, and this is methyl, so it's become n-methyl aniline. So this is the common name. Now how about the IUPAC name? If we are having a kind of straight chain, so we have to give the priority. So for example, in this case this is sorted, that is methane amine or IUPAC, that's it. Okay, in this case if you're counting the carbon, one carbon, two carbon, one carbon, two carbon, so one is go with the n, so it's become n-ethyl, N-ethyl, and one become ethane amine. So N-ethyl, ethane amine. And in this case, if you're observing again that this side 1 and 2 carbon, and here only 1 carbon, and here 1, 2, and 3. So out of all the three cases, this is my parent chain. Okay, this is the parent chain because there's a 3 carbon present. So whatever be the parent chain is a part of the amine there. So like this is a kind of parent chain, and then it's become n-ethyl, n-ethyl, okay, and then n-methyl, and then it's become propane amine. So this is how the name for this. And for this, and again, that n group methyl, so n-methyl aniline is there. This one we already discussed. So this is how you can go with the normal IUPAC nomenclature. That's it. This is all for the name. Naming is not very difficult here. Done. Okay. Very good evening, Meera. After so many days. Okay, good to see you. So observe again. Let's see the next point. That is a physical property. So physical property wise, first of all, physical state and appearance. Okay, that how about the physical state and appearance. So observe this slide again. That aliphatic and aromatic amine are colorless. Okay, so it's not very colorful family, normal colorless, and color can be changed due to the oxidation with atmosphere. Okay, maybe you know that it's a famous reaction of the inorganic chemistry that whenever the nitric acid, okay, whenever the nitric acid, for example, if let's suppose we are having HNO3, okay, so it's strictly there that you have to store the HNO in a dark place. Why? Because if it is combined with the oxygen, oxidation have to be there, and just because of this, it is going to break, right? And the color change, the color of the NO2 gas. Can anyone, you have to tell me that what is the color of the NO2 gas? Nitrogen dioxide color. Yes, please. Anyone? How about the color? You already covered the inorganic chapters. So what is the color of the NO2 gas? Yes, very good, Amik. It's going to be the brown color, right? So did you notice something that what is written here that automatically like in the very first they're not colored compound, but once they undergo oxidation, like nitrogen is not colorful, like N2 gases have no color, but once it's become NO2 or undergo oxidation, yes, it's attain some kind of color. That's it. In general, like 1 to 3 carbon gases, we know that lower part, lower carbon or the lower alkane system is most of the time gases, and as we are moving further, so it's become liquid and solid there. Higher the number of carbon, so more is the solid character have to be there. Okay, so this is normal. How about the smell? I guess you already know fishy smell and that very bad smell of the ammonia. So if you're talking about the order there, so lower aliphatic amine, like fishy odor and very bad smell for the nitrogen compound. Next one is the solubility in water. So yes, everyone we know nitrogen or the like amine are soluble in water. Reason is what? Hydrogen bonding. Okay, so let's understand how. So in this case, observe this. This is nitrogen. And let's just talk about the primary amine. So this is hydrogen, this is hydrogen, this is some R group there. Okay, and nitrogen also have some lone pair as well. And this is my water. Okay, oxygen also has some lone pair. And maybe you already know that oxygen form a bond with the hydrogen there. And which kind of bond this is? Hydrogen bonding, right? It's a hydrogen bonding. So just because of the hydrogen bonding, the amine have very good solubility in water. Okay, which chapter? P block element. Yes, you're right, Shiva. So I know that this P block is not the part of the board exam, but still go through. Okay, simple, and it's a very common sense question, although because we already discussed so many times. Okay. So please revise the chapters whenever if you leave that chapter. Okay, so let's just back again. This is the first point that they are having a very good solubility in water, like dissolve like. And the same thing that if you're considering the organic solvent be like benzene or toluene, very bad solubility. Okay, now my question for you, for example, that this is a kind of question. If there is a CH3, CH2 and OH, A, okay, and a CH3, CH2 and NH2. So can you just tell me between A and B which is more soluble in water? Okay? No, 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 it's first session. Yes, please. A or B. Okay, okay. Yes, A or B. I guess it's very simple question. B, okay. Like alcohol is more soluble or like amine are more soluble in water? So just go with the hydrogen bonding, right? So we know the trend of the hydrogen bonding. What is the order of the hydrogen bonding? That if let's suppose you are having a HF bond. So HF has a strong hydrogen bond as compared to the HO bond as compared to the HN bond, right? So in this case, if you're observing the common is thing is what this is a common part. But in this case, this is oxygen. You know, oxygen is more electronegative as compared to the nitrogen. So what is the basic criteria for a hydrogen bond? That is first of all small size. Now you're right, Venom. No, no, Ambika, that option E is going to be the correct because what is the hydrogen bonding criteria? First of all, small size of the atom, and the second one is what? High electronegativity, right? So in A, oxygen is smaller in size. Okay, okay, you have to tell me. Just wait, I will take your question. Okay, yes, please. So obviously, according to the size and according to the electronegativity, oxygen is smaller in size. Maybe you're not getting my point. So listen, that for the hydrogen bonding, what is the point? Two point we're requiring. The point number one, small size of atom. So that's why, like size order wise, fluorine is smaller in size, right? Then followed by oxygen, then followed by the nitrogen. We discussed so many times that as a fauna is the dawn of the periodic table, right? So it's a small size. And then if we go with the electronegativity, so high electronegativity, so electronegativity wise, what is happening there? That is fluorine is more electronegative than oxygen, than nitrogen, right? So according to the electronegativity wise as well, fluorine is the winner there. So technically that HF has a strong bonding over the HO molecule over the H in there. Okay, so for this is the first criteria. Okay, I will take this question later. Just wait. Okay, so that's why this is going to be the correct answer. That A is more soluble as compared to the nitrogen there. Okay, so reason is what? Small size of the oxygen and the high electronegativity of the oxygen. Is this point clear now, Ambika? Okay, now let's talk about the acidic part, right? So, what is acid? This is HF and this is water. So, once it's being like acid, so H positive and release from this as well and from this as well. It's become F negative, it's become OH negative. And please, you have to tell me between A or B which is the stable or which conjugate base is stable, and you will get your answer then. Yes, A, I guess your name is Abhishek, right? So, according to you, like which one? OH. But I know according to the electronegativity order, fluorine, then oxygen, then nitrogen, right? Then how you're saying OH? So, listen my point that if you're to go with the the electronegativity concept, so this is very simple. Listen, that along the period or across the period, if we are talking, so you have to consider electronegativity. Okay. So what is the point? That F negative is much more stable over the OH negative over the NH negative. Okay, and ammonia, okay, 3 NH2 negative. So this is the case. And if we are moving down the group, because across the period, size is not an issue, electronegativity keep increasing there. But down the group, if you have to observe, that is size is the important part here. It means that down the group, for example, if you will be having I negative, so I negative is much more stable as compared to the bromine negative, as compared to the chlorine negative, or as compared to the fluorine negative. So what could be the reason here? That is down the group, negative charge like have more space, or you can say that is the charge spread there. Okay, but in the point number one, that you have to go with the electronegativity, because the electronegativity play a very much important role here. Okay, so wait, I have to change the position. I guess it's now visible. Okay, so B noted, it's not like OH negative. Okay, this is the point number one. And the second question, most of the time I'm observing in the group chat as well, that you are having a issue with the hydrogen bonding type of question. Okay, for example, let's see a question for you. Okay, you have to just let me know like in which case we are having maximum hydrogen bonding. Okay, so the point number one, this is HF. So it's a, it's a B. I wait, I have to change the positions. So it's a fluorine, hydrogen. Yes, please. Arrange the A, B, C in a order of increasing or decreasing trend of hydrogen bonding. Yes, please answer this question. A. So you mean to say A has a maximum hydrogen bonding, right? A. Okay. Yes, everyone. What is your point of view? Because I just mentioned to you HF and then followed by HO and then followed by the H in there. Okay. So like this is a misconception actually. Because let me tell you how. Wait. Yes, anyone. I guess this is a very simple chemical bonding question. Still, you're not answering the question. Hi. Okay, Abhishek. Okay. So actually, the correct answer for this question is really option number A. Okay, but like how it is possible? Because we just discussed, isn't it like this is HN bond and this is HO bond and this is HF bond? So maybe you will be like, ma'am, you just mentioned HF has a stronger hydrogen bond. Then why option A is the correct? And let me tell you one thing, that in this question the order is what? A followed by C and followed by B. This is the correct order of the hydrogen bonding. Okay, so but why this is the order there? So listen my point, it's very very much important there. Okay, so just try to understand, this solid is a covalent bond. Okay, this solid is a covalent bond, and everyone, hydrogen bond is a weak force of attraction. Okay, don't say, ma'am, no, hydrogen bond is the stronger one. No, all are the part of the weak van der Waals force of attraction. If you remember that dipole dipole interaction, dipole induced dipole, ion ion dipole, ion induced dipole interaction, London forces, and even hydrogen bonding is updated version the dipole dipole interaction. Right? So in this case, simply just try to understand that, okay, electronegativity wise, that okay, fluorine, this one and this one I have to select. But in this case, observe the point number one, that nitrogen be like hydrogen, you want to make a bond with me, like I'm having a partial negative charge and you will be having a partial positive, and similarly that is partial positive and partial negative. Okay, so in this case, if you're observing something, this fluorine is what? That fluorine is connected with one more hydrogen. Similarly, nitrogen is connected with one more hydrogen. So think about it, that in this part, that is option number C. If hydrogen already connected with fluorine, okay, and this is also fluorine. So if this fluorine is already also connected here, so fluorine will like, hydrogen, just come toward me. What is so special about the fluorine? Just try to observe this, that the side atom, the side fluorine try to break the solid bond, the covalent bond. So just it's just a weak interaction. So the interaction is not so strong so that it can break the covalent bond that is already present. Okay, so this is very much important point, or maybe you already know the rule of the that hydrogen bonding, that this atom is less electronegative. Okay, this is less electronegative. Why? Because if it is more electronegative is there, so obviously it's going to break the bond. So how to select that? Like this is a common HF select, and then this has a maximum hydrogen bonding and then followed by the fluorine. Okay, and in this case this is not an issue because already oxygen is present. This is how you can tackle. Okay, so it's very important type of question. Okay, of course I will sort. Okay, let's say this is some X, this is some Y, and this is some Z, let's say. Okay, so dotted part. So what is the hydrogen bonding? Hydrogen bonding is directly proportional to the electronegativity. This is hydrogen. Okay, let's say, because we are discussing hydrogen bonding. So hydrogen bonding is directly proportional to the electronegativity of X. I don't know. You can take any A, B, C, okay, whatever you like. Or this is inversely proportional to the electronegativity of Z. Okay, this is hydrogen bonding. This is the rule. Okay, I hope now it's clear. Okay, Abhishek, is this okay now? Okay, welcome, not an issue. So let's just back again what we're discussing, right? Solubility part. So I hope this question is no, this not. Okay, this question is clear for you, right? So let's just back to the solubility concept, what we are discussing. Solubility, solubility, solubility. This part done. Yeah, solubility. So look at this, what is written here, that in a solubility, that lower aliphatic amine is soluble in water and higher is the amine, that we know that branching keep increasing or the number of carbons start increasing there. So that solubility start decreasing because more is the number of carbon, so much hindrance is there and solubility automatically start decreasing there. So like lower aliphatic amine are soluble in water, but once that the number of carbon increasing there, so it's insoluble in water. But it's different, right? Means different be like how? For example, just answer this question. Simple, answer this question. That CH3, CH2, CH3, A, CH3 and CH3. Can you just tell me which is more soluble in water? Not water. Which one has a maximum solubility? Simple. Answer this question. Wait, I will explain. Just wait, Venom. A or B, which is more soluble? It's not boiling point, okay? Okay, B. Okay, so very good. B is the correct answer. Why? Because small. Think about it. If I'm having a very, like let's say the large bowl of a salt, okay, or the rock of a salt, right? It's very difficult for us to dissolve that rock of salt into water. Otherwise, if let's suppose we're having very small crystal, it is easy to dissolve, right? So what is happening? Small is the size, more is the solubility. So B is the final answer as compared to the A, right? So this is the simple thing I'm explaining here. Now listen my point. What about the nitrogen or like nitrogen containing compound as well? If this is nitrogen, okay? So in this case, this is hydrogen and this is hydrogen and this is hydrogen. This is normal ammonia. Okay, the point number two, that if we are talking about a primary amine, this is the primary amine. Okay, it's a primary amine. And if let's suppose more R group is connected, let's say this is R and H. So noting something, that as the degree start increasing, that primary, secondary to tertiary there, so what is happening in this case? First of all, three hydrogen. Okay, now two hydrogen, now only one hydrogen. So what is going here? That simply hydrogen bonding. So in this case, three hydrogen bonding. But in this case, only two hydrogen bonding, and in this case, only one hydrogen bonding. So it means that if we are moving from ammonia to amine to the secondary amine there, so what is happening? Solubility decreasing there. Reason is what? Because decrease in a hydrogen bonding, just because of the hydrogen bond, hydrogen atom is not there. Like tertiary is very, very less soluble in water. Okay, so this is how you can go with the solubility. Wait, wait, is the slide? Okay, so I guess this point is now clear for you. What is the statement? That higher amine insoluble in water and due to the presence of longer hydrophobic chain, the point number one. And the second point is what? Hydrogen bonding is also the reason there. Okay, so this question we already covered, that why this is more soluble as compared to this one, because oxygen bond, high polarity, more soluble in water. This is decrease in polarity, less soluble in water. Okay, so let me just quickly give you a quick recap till now. In the very first, we discuss about that is what is amine, what are the uses of the amine. Okay, yes, of course. And then we discuss about kind of property, nomenclature, and then property this. So the property number one, physical property like order wise, smell wise, and then we discuss about that the solubility in water. So first of all, amine has a very good solubility in water. Reason is what? Hydrogen bonding. Okay, but if you to compare between alcohol and amine, so alcohol is more soluble over the amine just because of the hydrogen bonding. Okay, because oxygen is smaller in size and high electronegatividity. And then we discuss about if we are moving from lower to higher number of carbon, so more is the number of carbon, more is the hindrance, and lesser is the hydrogen bonding just because of that the solubility start decreasing there. Okay, Venom, I hope this point is now clear for you. So that's it. Now let's discuss about the solubility of amine in organic solvent. So although this is already very much polar, but it is not very very frequently soluble in organic solvent. So amine are less are soluble in less polar solvent, be like alcohol, ether, and benzene, because we know like dissolve like polar dissolve in polar, non-polar dissolve in non-polar. Okay. Second point, that boiling point. I guess the third property, boiling point. So how about the boiling point? Boiling point is very simple thing again, that more is the hydrogen bonding, lesser will be the boiling point. And I guess you already know from the boiling point is what is happening there, that more is the branching and lesser is the boiling point. Okay, so straight chain, more is the surface area, higher will be the boiling point. And in this case, what is written here? That primary, secondary amine are engaged in intramolecular hydrogen bonding. It's in between, right? In between. And just because of this, between the nitrogen of one atom and a hydrogen of another molecule. For example, if let's suppose this is my, wait, it's not visible, right? So for example, if this is nitrogen, this is some hydrogen, this is some R, this is some R, it is participating in a hydrogen bonding with a different nitrogen there. So it's what? It's a inter, in between the molecule, inter type of hydrogen bonding, right? So this is back again. So it's normally not the slide written here, that intermolecular hydrogen bonding between the nitrogen of one atom and the hydrogen of another atom. And if we are going to discuss about the hydrogen bonding again, it's a primary two hydrogen bond, and in this case one, and in this case zero. So if you are moving from primary to secondary to tertiary, mean hydrogen bonding starting decreasing there. So intermolecular hydrogen bonding between nitrogen and the hydrogen is higher in primary than secondary and then tertiary there. Okay, it's not a new thing. Whatever we just discussed is a repeated portion. Now let's see the next point, that is boiling point. So primary is has a maximum boiling point, then followed by secondary, then followed by tertiary. The answer is what? Hydrogen bonding there. So observe this, it's a straight chain branching, and more is the branch, lesser is the boiling point. So simple. The normal, the same concept, that is boiling point is directly proportional to the size. Okay, it's directly proportional to the surface area. Okay, and inversely proportional to the branching. This is all for the chemical property or the basic part of the amines. Now let's talk about the important part. Now the real part start, preparations. Preparations of amine. Some preparation you already know from the previous classes, because this is a beauty of the organic chemistry. If you already know the the some portion, so some is the repeated topic already. So reduction of nitro compound, then ammonolysis of the alkyl halide, then reduction of the nitrile, then reduction of the amide, then that is the Gabriel thalamide synthesis. This is going to be very much important, and some rearrangement reaction. So if I have to say that important topic, so these last two topics are really, really important. Okay, it's not like these three, four topics are not important, but not very, very important. So let's see some important part for the nitro compound. So some topic we already covered, if you remember, that if you are having a nitrogen compound, go with the catalytic hydrogenation. What is catalytic hydrogenation? The same H2, PD, platinum, platinum, same catalytic hydrogenation. So let's see that how we have to go with catalytic hydrogenation there. So let's just suppose if I'm having this nitrobenzene, okay, this is nitrobenzene, and in this case, if I'm using H2, platinum or platinum, so what is happening there? That NO2 group is converted into the NH2 group. So what is this? This is reduction. Why this is a reduction? If you're observing something there, two oxygen, now zero oxygen. So loss of oxygen and gain of hydrogen. Here zero hydrogen and now it's become two hydrogen there. So it's simply a reduction is going on. Okay, so the point number one, that is the preparation number one. So observe this, that H2PD you can use, or like this is for aromatic, this is for aliphatic. This is catalytic hydrogenation. Now let's just talk about the second point, that treatment of acid in the presence of some metals. Okay, so let's see how. Okay, so there's a some kind of nitro group again, and in this case, the most common is what, Sn plus HCl you can use, or that is the Fe plus HCl we can use. Both we can use. And what is happening there? That is, there is a formation of aniline one more time. Okay, this is aniline and this is our nitrobenzene. Okay, so the topic name is what? Catalytic hydrogenation, sorry, acidic hydrogenation in the presence of metal. So Sn and Fe we can use. But do you know, if you were to prefer, like preference wise, this is more preferable there. Why? Because if you are using iron, okay, so what is the side product for this reaction? HCl as a side product. So noting something that we are using acid plus metal. So with iron, if you're using the iron, what is the plus point? Along with the aniline, the HCl is a side product. So in this reaction, no need to use extra HCl from outside because HCl is regenerated. So yield wise, the reaction number two, the reaction with FeHCl is good there. So that's why we are using frequently the iron one, not the Sn. So let's see the statement how like it's look like statement wise. So yeah, observe this. So like what is this written here? That by reduction of nitro compound treatment with acid, you can use Sn as well, or you can use Fe as well. Okay, metal plus HCl, you can use an aniline, and like if you're using alkyl, so we're getting alkylamine. If you're using aryl, so we are getting arylamine. But the reduction with FeHCl is preferred because of the HCl is regenerated in the reaction, and thus a small amount of HCl is required for the reaction. So yield is going to be very good. That's why we have to prefer the amine here. Okay, so this is all for the first second method, that is reduction with metal there. Now let's see the last method in the reduction one, that is electrolytic reduction. So if this word come into the picture, electrolytic reduction, so we are going to use that same cathode and anode. Okay, but again, we are not going to discuss about like cathode or anode. So let's discuss about some very much important part. Okay. Yes, Fe and Sn. Fe is means iron, and okay, wait, I will. So listen, if I am using Sn, okay, plus HCl. HCl is a solvent. So what is happening? This is NO2 and this is aniline. Okay, but if the same reaction we are using Fe, so what is happening there? That is aniline, like the first reaction, and the second one plus HCl is also generated. Okay, so think about it that we are requiring HCl, so HCl generated and again transfer this. So it's like cyclic process. It's kind of regeneration of HCl in this reaction. So no need to use more HCl. But on the other hand, if you're observing the first reaction venom here, so in this case, no HCl generated, nothing. So we have to use more HCl from outside. So consume, in this case, HCl consumption is more as compared to the iron one. That's why we are preferring the iron over the SN. Is this point clear now, Venom? Yes, please. If not clear, let me know. I will explain one more time. Okay. So let's go again. What we're discussing. So this is the third one, electrolytic one. So again, that you will be having some nitro compound and we undergo the reduction part there. So reduction will like, first of all, nitrogen is there, like nitro compound, any nitro compound. So in this case, this is a nitro compound. And if you to go with the catalytic reduction, okay, sorry, not catalytic, electrolytic there. So there is a four electron, okay, four electron. And wait, let me just first write the reaction and then you will tell me what is happening. 4H positive. And then there is a formation of this NNOH. So it's what? It's our phenyl, okay, phenyl hydro. Phenyl, it's a hydro, okay? Phenyl hydroxyl amine. Okay, this is important name. Let me just write one more time. Phenyl, and just because of this hydro, the hydroxy is the prefix of the alkyl family. So it's a hydroxyl amine there. Now, my question for you, from here to here, what is this? Is it oxidation or is this reduction? Yeah, like regeneration. Yes, please. Hydroxymic acid. Huh, you can say. But like if you're using phenyl one, so like hydroxymic acid is particularly only for NHOH group, right? The reduction oxidation. Hmm. Okay. Okay. So in this case, observe this. In the very first, you are having two oxygen, right? And now there is only one oxygen. So what is happening? Loss of the oxygen. So now what does it? It's a reduction, right? And see, on the top it's written 4 electron. It means it's consuming the 4 electron. Okay, consumption of the 4 electron, and then there is a formation of this. Okay, like what is happening? It trapped the 4H positive ion, and then 4 electron is there, and there is a formation of this. So what is it? It is a reduction basically. Okay, so like it's a cathode reaction. So on the cathode, what is happening? The reduction is there, so it's a reduction there. The point number one. Okay, so it's a common point. It's a common thing that we are getting here. So it's a point number one. In the same reaction, in the same reaction, if I am using Zn, okay, it's really very important part. If you to change the reagent, we are end up with a different product. If you are using that Zn ammonium chloride, okay, so maybe you'll be like, ma'am, it's the same. Then what is the difference? So in this case, it's become same thing like this and this. If you're using Zn ammonium and that NH4 and Cl there. Okay, so this the reaction stop till here only. The point number one. I'm repeating one more time. If you are using Zn ammonium chloride, so what is happening? This is the final product, that phenyl hydroxylamine. But if you to use only acid, plain acid without any Zn ammonia, zinc ammonia use, then let's see what is happening after this step. Next slide. Okay, so I will brief at that. Wait, and this is NHOH. So if we are using if we are using weakly acidic condition, so what is going to happen? Let me highlight that. What do you mean by weak? Okay, it means that added on that side. Aniline form, the point number one. Aniline. When we're using weak acid, acidic condition, and if you're using strong acid. Okay, be noted, it's not like strong acid be like HCl, weak acid mean acidic acid. No, condition be like means more acid if you're using, so it becomes strongly acidic condition. I said strong acidic condition. I'm not saying that is a strong acid or a weak acid. Okay, so condition be like amount of acid deciding is the deciding factor. So let's say H positive strongly. So the final one is what? That NH2 is the common thing and plus OH is also connected here. Okay, this is important. Okay, I will repeat one more time. First of all, that we are using only acidic condition. Okay, okay, wait. If nitro group, okay, if you have to go with the electrolytic reduction, okay, if strong condition, so reaction stop till aniline only. If you're using, sorry, weak, if you're using strong one, so it's become that is for that, okay, the name. In terms of the naming, aniline is more dominant than the phenol. Hmm. So yeah, the next question for you. I'm not mentioning the dominance here. This is NH2. If strong acidic condition, so NH2 is the common point and OH connected here. So yes, answer this like name of this compound. And if you're using weak conditions, we are getting aniline. If you're using Zn, NH4, Cl. Okay, so reaction stop here. So it's not like in between these two steps, this is also formed, but reaction is not going to stop here. Okay, first of all, this is the intermediate there. So this is, I guess it's clear now that in this one, only acidic condition, this is an intermediate, and if strong, reaction stop here. If weak, reaction stop here only. Okay, and now please name for this. Okay, no. Here, my point is not that we are using weakly acidic condition or strongly acidic condition. Okay, K1O4 K2Cr27 is a oxidizing agent, and PCC, PDC, toluene phthalate, these are just behaving like a oxidizing agent. One more time. Okay, so here condition will like, for example, that if I have to highlight to you how that let's say there is a some R, okay, there's a some R, and if I'm using 4H positive ion, so I'm using more acid, or you can say concentrated acid simply. Okay, but if I'm using 2H positive, so this is my weakly acidic condition, this is my strongly acidic condition. Is this point clear now, Agastya? Okay, Agastya, where are you? Okay then, so let's go. So back. Okay, I hope now the mind map is clear for the reaction. Now let's read the statement, okay? So let's go with the statement part as well. Okay, so now take your time and read the slide. The point number one, electrolytic reduction in strong acidic medium give para amino phenol. Okay, so yes, the next question. Okay, I just missed that question. What was the name? Like it's going to be the 4 hydroxy or uh, that that 4 amine group. No, it's not hard. So the name become para aminophenol. So what is the priority of the which group? Okay, I don't know you know or what. Okay, so listen my point. Priority wise, alcohol has a maximum priority as compared to the amine group. Okay, so priority wise, that RCOH group followed by RSO3H group, followed, and then ROH group. Okay, and maybe you already know that it's followed by that RNH2 group, and even NO2 group or halogen group or phenyl group. Okay, these three type of thing, or yeah, ether as well. Okay, so they are just behaving like a substituent. Even they are not the part of the functional group priority table. Okay, so if you are comparing the priorities, so OH has a maximum priority over the amine. Okay, so I guess that Agastya is not there. So I guess this point is clear for you now that OH has the maximum priority. Okay, so that's why the name is what? It's para amino and then phenol. Okay, it's not para hydroxy then aniline. Okay, maybe you are getting my point. Anyway, let's just back. So it's para amino phenol. And if you're using weak condition, like by the rearrangement, phenol, that hydroxy, like yeah, this one. So in this case, the rearrangement is going to happen, and then there is a formation of that thing. We will cover this reaction. Wait for. And the electrode reduction by neutral reducing agent be like Zn ammonium chloride. I already highlight to you. We are just end up with only this. Okay, so normal is what? If you are using neutral reducing agent, reaction just stop till that phenyl hydroxylamine. But if you are using stronger one and then especially weak condition and a stronger one, then we are getting a different product. And now let's talk about this step. So it's that Mulliken-Baker test. Actually, what is this? You know, this that phenyl hydroxylamine react with Tollern reagent, react with Tollern reagent and give Tollern test positive. Okay, listen my point one more time. That Tollern test given positive only by the aldehyde group, right? If you remember, or that is a methyl ketone if you remember. But what is happening in this case? No CO group or carbonyl group present there, but still it is a Tollern positive test. So if the Tollern test given positive by this phenyl hydroxylamine, so it's become a new name, that is a Mulliken-Baker test. Okay, so sometime the name be like Mulliken Baker test. So it's nothing, it's just a updated version of a tolerant test for the hydroxylamine there. And it's converted in the NO. It's not NO2 NO. Not NO2, it's a NO there. So now back. Let me just brief the same reaction in a single line. Actually, what is happening? So you have to start with NO2 group. Okay. So in the first one, Zn plus ammonium chloride if you have to use. It's not like I'm chasing the position because here space is okay. Wait. Let me write here. And then we're using Tollern reagent. So this is formed. This is the only reaction which we're going to remember from this topic. Important. Okay. So first of all, strong, weak, aniline. Okay, and this is Tollern. This is that Mulliken test. I hope the brief is clear for you. Okay. So this is the single kind of reaction that we are going to remember. And it's already asked so many times in a PYQs. If you're solving the PYQs properly, so it's important. Okay, now you can note it down, and I hope it's clear now, the last part. So let's just back. Okay, this is all for the preparation. Next preparation we are going to start in the next class. Okay, let's see the last one. Okay, it's simple ammonolysis. So what is ammonolysis? This is one of the easy. Okay, the previous one is difficult. So you are having some Rx and this is ammonia. So you know ammonia has a lone pair, it attack here, X is going to release. What is happening there? That R is combined with the nitrogen, hydrogen, and hydrogen. Still nitrogen has a lone pair. Again, there is a one more Rx, lone pair attack here. This group is going to release, and the process keep going on, going on, going on. Till then, all the like hydrogens replaced there. Again, this is Rx, ammonia attack here. So what is happening there? This is N and this is R, this is R, this is R. Still oxygen has a nitrogen has a lone pair and this is combined with Rx and it is attack here. What we are end up with quaternary amine there. So means what is the important part, that if we want to stop the reaction till this only, that only amine. But the reaction is that much fast that nitrogen as a lone pair processes keep going on, going on, going on, and at the end we are just end up with the tertiary or quaternary amine there. So means reaction is not feasible technically in a labs, but simple the preparation part. So that's why. Let's just back again. Observe this, that ammonia simply come attack here and the reaction stop till quaternary amine only. If you're observing that more are added, secondary more are added, tertiary more are added, it's become quaternary. Okay, so although this method is not good, like this method is very limited synthetic application because multiple alkylation occur. So laboratory wise, it's not very good for you. Okay, so that's why we avoided the use of this reaction for the preparation. That's it. Now let's see a question. Okay, just question part only, and then we are going to add the class. Which of the following reaction is an example of ammonolysis here? Yes, please. Quickly supported this zwitterion. No, no, zwitterion is not there. Okay. Actually, that reaction is easy, so that's why I'm sorry. Yes, which of the following reaction is an example of ammonolysis? Okay, Shivam. So just check it for in which option the ammonia is added. I know it's easy, that's why I was fast there. So let's see how. In the first one, it's cyanide group and it's become NH2. It's not addition of ammonia, right? It's wrong. And in this case, CO isn't, it's kind of, there's a formation of amide. So it's wrong again. Okay, it means wrong. And then HCl again, it's already amine present, okay? And it's not ammonia. So look at this clear cut, right? Addition of ammonia, monolysis. So ammonia is adding, and that's why we are getting this is the correct answer. Now, one question for you. If in this reaction, if in this reaction ammonia is a common, okay, ammonia is a common thing, and I am using Ri, I'm using RBr, I'm using RCl, and I am using RF. So in which case the rate is fast? In iodine part or in A part, in B part, in C part, and D part? Yes, please. Which, yes, Ambika and Venom, you're also right. Yes, which one is going to react first or fastly? Iodine, bromine, chlorine, or fluorine? If ammonolysis in all four cases. Of course, iodine, right? Why? Because it's nothing, it's a kind of substitution kind of reaction there, right? Addition reaction simply. Yes, A there. Rate. We discussed this so many times on a nucleophilic reaction there, that Ri, why? Because iodine is large in size and R is smaller in size. Okay, so what is the order there? That Ri or the rate of the reaction? So rate of ammonolysis. So the rate of ammonolysis is Ri followed by RBr followed by RCl followed by the RF. Okay then, that's it. Last question, please answer this. Electrolytic reduction of nitrobenzene is in weakly acidic medium give aniline, nitrosobenzene, Okay, or N-phenyl hydroxylamine or para-hydroxyaniline. If you don't know what is this nitrosobenzene, okay, so wait, let me just write the name on that slide where we discuss about this. Slide, yes. This is nitrosobenzene. Okay, it's a nitrosobenzene. And see, this question is just a PYQ. I hope you're able to answer the question. Yes, please. Electrolytic reduction in weakly acidic medium give A, B, C, D, or what? Okay, Ambika. Yes, you're right, Shiva. Okay, Venom. Okay, so I guess question is easy, and that's it. You're not sure, no? You're you're right, okay? Option E is the correct answer here. Why option E is the correct here? Because see, nitrobenzene, weakly acidic condition, we discussed, right? If weak, just think about it. Weak means only one position substitution, right? That if I'm using weak acid, that only aniline. Okay, if I'm using strong acidic condition, so OH is also connected there. Okay, so just be noted, weak, one substitution, and strong, so two. So this is how you can remember. I used to remember like this only. So weak, aniline formation there, and hence option A is the correct here. Okay, if question mention you are also using Tollern reagent or that silver ammoniacal nitrate solution, so option B is the correct here. If we are using strong acidic condition, so it's become para-hydroxyaniline. And if we are using Zn plus ammonium chloride only, so we are end with option C as a correct here. Okay, so like every reagent has a different answer, right? So I hope now this point is clear for everyone. Okay, how to use that simple a single slide for every part. And this is very important topic of the amine chapter. Okay, no, actually I have no time for this. Okay, so I guess it's clear for everyone. If you are having any problem or any doubt, please let me know. Otherwise, let's go into end the class. Okay, thank you so much then everyone for joining the class, and that's it. Yes, please. Any problem? Quickly. What is your problem? Okay then. So good night. Thank you so much. Thank you so much, everyone. Have a nice day. Bye bye all. Thank you.